John Nerrill. John Nerrill is a mathematics assessment specialist and a member of Casio's Teacher Advisory Council. He has taught for 16 years and has presented at conferences from the local to international levels. John has also authored several books, including the Barron's New Jersey Ask Grade 7 Math Placement Prep books, as well as numerous books and curriculum materials for Casio America. In his spare time, John can be found actively competing on the Professional Bowlers Association's regional tour, where he won his first PBA regional title in 2010. Welcome, John. It's good to have you tonight.
Thanks, Dee Dee. It's a pleasure to be here, and welcome to everybody that's online this evening. I hope everybody's having a good day, and again, I appreciate the time everyone's here just to engage in a little bit of a discussion tonight on from unit fractions to mixed numbers. And I just want to preface tonight by saying that this is such a broad topic and a rich topic that it's really impossible to cover everything there is about unit fractions and numbers and operations and fraction understanding that's found within the Common Core in the scope of an hour. But for tonight, I do want to frame just a couple of things to help us with that, and so kind of set up this little agenda for us this evening. So we're looking at four particular topics. So one is just to explore the meaning of a fraction and several ways that fractions help build numerical reasoning. We'll talk a little bit tonight about unit fractions, why they're important, why students need to spend a lot of time understanding the concept of a unit fraction, particularly in grade 3, and how that knowledge helps support and build on their numerical reasoning and understanding throughout middle and high school. We'll talk about some computational fluency when working with fractions, and then finally, we'll take a look at several released assessment items that address understanding of fractions. Here's a couple of research points for where I pulled some information from tonight. Certainly Bill McCallum's website out of the University of Arizona and the progressions documents around the Common Core. Tim Kainold's book, Common Core Mathematics and the Professional Learning Community at Work. The Illustrative Mathematics Project. Casio Education's website with all of its resources and materials that are there. CoreStandards.org for the Common Core State Standards, and the Smarter Balanced Assessment Consortium, where we'll take a look at some of their released sample items. I also want to say that it would be unfair at this point to not acknowledge the fact that there certainly are states that have not adopted Common Core. But within those states that have not adopted Common Core, this seminal knowledge, if you will, of fractions and how fractional fluency and understanding of fractions is built parallels across. So while I will be making references to some of the Common Core state standards this evening, if you're a part of a state that has not adopted the Common Core, I'm positive that somewhere along the way the information that we're going to talk about tonight is very relevant and lives somewhere of a place of importance within your own curriculum materials and pacing guides and such. So what's a fraction? We know that understanding of fractions begin very early on in grades 1 and 2. It is the notion about partitioning a particular shape into equal shares. Okay, so kids begin to get an understanding about what it means to have the same and what it means to have something that's different. So if we have something that we want to share, Dee Dee and I are sharing something and we're going to share that equally, she would get 1/2 and I would get 1/2. And for kids, that understanding of that equal part is that it's the same. Okay, so if I have let's say 2 cookies or 1 cookie, and I want to cut that cookie in half so Dee Dee and I each get an equal part of it, there's something tangible for me to understand that we each have the same. And then that naturally leads into what we see in grade 3 with partitioning those shapes into equal parts and having an understanding about what that fraction means in terms of what the numerator represents and what the denominator represents. And one of the things that we see, whether we look at the work of the Language in the Common Core, whether we look at Tim Kanold's book, if we look at some of the curriculum materials from Marilyn Burns or John Vanderwall, is that whole notion of understanding what the numerator represents and what the denominator represents is key. And in that it talks about a relationship. So what does that relationship mean in terms of the context that I'm addressing, and how do I know whether I have something that's equivalent or I have something that's greater than or less than? And so if we take a look at this picture, I want you to take a moment here just to take a look at this picture to see what fraction this actually represents. So think about it for a minute and think about to yourself what fraction is modeled within this picture. So one thing that people have said when they look at this picture is that this picture actually represents 3/4, okay? And it represents 3/4 because we have one rectangle, and half of that rectangle is colored in green, and there's another part of that rectangle that's half colored. And so that would be 1/4, and so 1/2 plus 1/4 would be 3/4, and thus this picture here represents 3/4. But I'm willing to bet that there's probably some of you out there that are looking and saying, no, I don't really see it as 3/4, I see it as 1 1/2. And seeing it as 1 1/2 because there is one square that's fully shaded, and there's another square that's half shaded. And the truth of the matter is that both of those answers are correct. And so the reason why it's correct is that we've never truly distinguished or determined what is a whole, what represents the whole relationship here. And so it's important when we talk about fractions that we have a very clear understanding about what the whole entity or the whole part represents. Because if I look at this next model, and I said to you, okay, which is bigger? So I have a fraction, I have a circle that's divided into 4 segments on the left, and 2 parts are shaded in green. And I have another circle on the right, and only 1 section is shaded. So if I were to ask you which part is bigger, some might say, well, the one on the left is bigger because there are 2 equal parts. That's 1/2, and 1/2 is always larger than 1/4, which is modeled on the right. But then there might be some people out there that say, well, actually, it's the one on the right that's bigger because it's a bigger circle. And so because it's a bigger circle, that quarter is far bigger than that half of that smaller circle. So if how many times do we use examples of pizza, okay? But if I order a personal pizza and I only eat half of it, that's probably not going to be as big as if I order an extra large pizza and I eat 1/4 of that. So again, it comes back to that whole notion that we have to define exactly what the whole is that we're measuring and what it is that we're looking at, because otherwise I can't really make any kind of comparison or understanding. Yes, on the left I see 2/4 is colored in green, or 1/2, and on the right 1/4 is shaded, but I could never make a comparison between the two because they're not of the same size. And so then this last model down here, we see 5 squares. They are all the same size, and you'll notice that the 2 on the left are broken down into fourths, and 1/4 in each square is shaded in red, while the other 3 squares are representative of 1/4 as well, but they're shaded in blue. And so what the purpose of this graphic here is showing us is that we see equivalent relationships about 1/4 throughout, 1/4 being the unit fraction here. But there are some examples where that 1/4 is shown differently within a particular model. So for the third, fourth, and fifth squares that are there, yes, it represents a fourth, but it's either a 2/8 relationship or a 4/16 relationship that shows the equivalence that's there in comparison with the 1/4. So they're all equal relationships, but they are shown differently. Why are they equal? They're equal because they are representative of the same unit square, the same whole, and the same relationship, which is shaded in with all of those. What I love about these diagrams is that if you're using them with a group of students, or even if you're doing it in any kind of professional development training with staff, if there's any people out there that are working as professional development specialists, curriculum coordinators, instructional coaches, these are some great diagrams to engage your staff in and engage your students in, just around what they think about these examples. These are all third grade examples about fractions and the whole notion of unit fractions. And so I'd be remiss if we didn't spend a little bit of time talking about where fractions actually live within the Common Core. So the diagram that I'm showing you here comes from the Illustrative Mathematics project. The website is located there at the bottom of the slide. It's such an extremely helpful diagram, and for these particular purposes, you can read the diagram vertically and you can read it horizontally. So for example, if I look at the diagram horizontally, what I see here is that across the entire grade bands for K through 8, a student will deal with some aspects of geometry throughout grades kindergarten through 8th. If I jump down to the next row where it says measurement and data, students in grades kindergarten through grade 5 will talk about measurement and data, and then that information is foundational to help them talk about statistics and probability in grades 6 through 8. Well, what we see here then is that for numbers and operations that deal with fractions, they live in grades 3, 4, and 5. So the whole notion of a unit fraction, multiplying a unit fraction by a whole number, being able to operate with those fractions for adding, subtracting, multiplying, beginning stages of division that lead into grade 6, but it also ties in with grade 6 and 7 that lead to ratio and proportional relationships. We know that a student needs to have an understanding of that fractional relationship to be able to be successful when it comes to dealing with ratios and proportions. And when students are able to be successful with ratios and proportions, it sets them up for success when it comes time in grade 8 to talk about functions and to talk about linear functions in particular, in those relationships where we tie in the whole notion of slope. So for me, this is really helpful because I know that when students get a full, complete, authentic, solid understanding of working with fractions in grades 3 through 5, it's going to help make their middle school years more successful because of the knowledge that they've gained here. This chart here comes from Tim Kanold's book, Common Core in the Professional Learning Community at Work for Mathematics. And this is something that I've used in my practice. I find it particularly helpful because it's a really clean organizer to know what students are experiencing here. So developing an understanding of fractions as numbers. So students get to know that a fraction has a numerical value, has numerical meaning, has numerical understanding. And then after spending a year with that, going into grade 4 to talk about what equivalence and ordering means. So if I have 3 fractions, how do I know which one is greater than or less than another one? And how am I able to make those comparisons based on having some kind of equivalence? The whole notion of a unit fraction, to apply that unit fraction to operating with whole numbers. And how we take a unit fraction and multiply that by a whole number to get a particular value. We'll talk about that more a little bit later. And then the decimal notation for fractions and using them to compare fractions as well. some more work with equivalence in grade 5, but using that as a strategy to add and subtract fractions, right? To be able to know, I mean, we know from years ago, I know when I was in school, I remember my teachers telling me all the time that you had to find a common denominator because that was the rule. And I think what's so wonderful about the Common Core is that there's so much more of a conceptual understanding about knowing what that equivalence is and being able to use that equivalence to help come to an understanding of adding and subtracting those fractions, and then applying those to multiplying and dividing. And then finally, I would be remiss if we didn't just mention the standards for mathematical practice. And when I have worked with teachers and talked with staff, there's a reason why the standards for mathematical practice are in the front of the Common Core document, and that's because they're important. And they set up those habits of mind for students across the board for any learning that they're doing, whether they are kindergartners through high school students. And there are particular ones here that would be very easy to say, in my opinion, that when working with the standards for mathematical practice, that some are a little bit easier when we talk about fractions. So the modeling, attending to precision, to be able to reason abstractly and quantitatively. The truth of the matter is, like any parts of the Common Core, all 8 of these standards for mathematical practice are important. And I hope that through some of the examples today, as we talk about, and we'll take a look at where we can see structure and where we can see modeling and precision, and even using some tools here. So that whole notion of that unit fraction we talked about before, right, has to be based on a knowledge of what is representative of a whole unit. And then the unit fraction itself is a fraction in which the numerator is 1 and the denominator is an integer. So we have a half, we have a third, we have a fourth, we have a fifth. And it's important to note as well that the unit fractions have to be things that are tangible for students and relatable. So for a third grader, we wouldn't necessarily be doing a unit fraction of 1/7. But spending time working with halves, thirds, quarters, fifths, eighths, tenths are all relatable. And then we've seen these before, the fraction bars, the fraction models that show how this not only just the size of the unit fraction, but then making a comparison to know which one is bigger and why. So if I look at the halves, right, I need 2 halves in order to make 1 whole. And I can see the congruence there within the model. If I'm comparing a fourth and a fifth, or a third and a fourth, and I want to know which one is larger based on the same unit, I can see there with the model, with the tool, that the third is a little bit larger than the fourth. But for kids to understand that, where's the lift? Where's the challenge? Well, that denominator 4 is larger than 3. Shouldn't that be the larger number? Shouldn't that be the larger fraction? Well, then it gets into the whole notion about what that relationship is, right? If I have 1 whole unit and I separate it into 4 equal units, that unit fraction represents a certain part that when I compare it with another whole that's broken down into different parts, like a third, the third is going to be larger than the fourth. So here's another model that we use quite frequently, and that is a number line. And it's a number line with values at the top of the number line and values at the bottom. And what I really, really like about this is it brings in the notion of skip counting. So if we think about our elementary students when we learn skip counting, or we teach them skip counting when they're looking at hundreds charts, for example, and we have students counting by 2, and they're going 2, 4, 6, 8, 10, and they can be following along in the hundreds chart, moving their finger or moving a marker to go every other space to count off by 2. That's an important skill. We know that's an important skill because that leads to multiplication, it leads to division. So in skip counting with fractions and skip counting off of unit fractions, that's really important as well, because we want students to understand that in this case, when I'm adding a third to a third, there's a certain way that I count that off. 0/3, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, and so on. But as students become more familiar with this, we start transitioning them over to what an equivalent relationship means. So in this case, when they're skip counting, they're not just doing 0/3, 1/3, 2/3, 3/3. They're doing it as 0/3, 1/3, 2/3, 1 whole, 4/3, 5/3, 2, 7/3, 8/3, 3. And as you're doing that with kids, if kids are counting, they're going 7/3, 8/3, 9/3, we stop and we go 9/3 is equal to 3. Keep going. 10/3, 11/3, 12/3, so on. So the number line becomes one tool that they can use. Another tool that they can use is the calculator. And I say it as a tool because it is a piece of technology that students should know how to use. But I also firmly believe that it's not a crutch, right? Do I know that students should know that 1/3 plus 1/3 is 2/3 without pressing a button on a calculator? Absolutely. But what I've done before that I find particularly helpful is that if I enter in a third, okay, and I want to add a third to it, and what I've done here is just to set up a recurring formula that whatever the answer is, I'm going to keep adding a third to it. So now, every time I press the equal button, I'm skip counting. So it's 2/3, it's 3/3. And you'll see a little down arrow there, right? 4/3, 5/3, 6/3. Oh, wait a minute, there's that down arrow again. 7/3, 8/3, 9/3. There's that down arrow again. So that must mean something. So what I've done is I've set this FX55 calculator here to a manual mode to simplify. And so what this does is it prompts the student to say, you know what, this fraction could be expressed in a different way, in an equivalent way. So I can go to my simplify key here and I press that, and I'm going to enter the number that I want to simplify it by. In other words, in this case, what's the number that's common between both 9 and 3? If I put a 3 in and I press equals, right, the F is for factor, so it's a factor of 3, and now I get 3/1. And so that 9/3, that 3/1, is that point that I'm seeing here on the number line. And so that becomes a tool to use as well, especially if you have kids that are struggling with their skip counting. It's helpful, and so we have that there. It's a neat tool to use. That simplifying feature is neat. Years ago, we used to talk so much about expressing fractions in simplest form, and we know that the Common Core does not stress that because it certainly stresses equivalent relationships. But the fluency and the fluidity between those numerical relationships, there are times when it is particularly helpful, where we might want to see an equivalent form that is maybe not using such large numbers. So for example, 12/16. If I want to simplify it, and let's say this time I decide to simplify it by 2, and I see 6/8, but I still see that down arrow, which is telling me, you know what, we can still find an equivalent form there. So I'll do it by 2 again, and I get 3/4. So it does become an instructional tool that may help some of your students kind of gain some greater understanding with fractions, but should be used in conjunction with a variety of tools, like a number line where the whole numbers are written on the top and the fraction intervals there are written on the bottom. Kind of be helpful. Let's take a look at another.
We had a question before you move on. Presette, there's a question about the previous slide that you might want to address.
Let me go back.
I couldn't see the previous slide, so I wasn't sure how to answer the question.
Okay. This one here?
Is that the one you're referring to? It says, why did you use a drawing showing 1/2 is not equal to 2/4? I think it might have been that slide that you've got up right now. Come down. I'm not sure which one she's talking. Maybe that one.
This one here? Is it the one with the two squares and the green shaded?
Yes, she said yes.
So could you tell me the question again, please?
Okay, it says, why did you use a drawing showing 1/2 is not equal to 2/4?
Oh, the purpose of the drawing was to show that that actually can represent two different things. So it could represent 1 1/2, or it represents 3/4. And the reason why it represents those two things is that in the picture we've not determined what a whole relationship is. So this whole rectangle here could be one unit, with the line here dividing that unit into half. So this would be half, and this is half of a half or a quarter. So some people might think that this is 3/4, and it represents that. Some other people might look at this and say, well, really what it is 1 1/2, because we have one whole unit and half of another. So that these two individual squares here represent one whole. If the whole thing was shaded, it would be 2. But in this case, it's showing 1 1/2. So the point being is that we have to be very particular about the language that we use to ensure that students understand when we're building unit fractions that we're working off of the same whole or the same unit to represent it by.
John, if I could interject really quick, I think the question has to do with that lower graphic, and it looks like it's not quite calibrated is the best word I can come up with. Those two 1/4 you'll notice down there.
Oh, okay, I see.
And so on and so
forth.
It's
probably how I captured the image and fit it to fit the slide. So it's not intended to be that way. They are supposed to be equal units. I think it's a way that I captured the image from the internet and put it into the slide. Is that helpful?
I do think that answered her question.
Not helpful okay, yeah, it's not helpful if the image is wrong. We'll have to fix that. But yeah, no, thank you for bringing that up. I appreciate that. It's definitely one of those kind of things when you're looking at stuff all the time, and yeah. So no, thank you for that. I appreciate it. Good. Are there any other questions at this point? I know we've been going for a little while here, so. Dee Dee, do we have any other questions?
I don't see any other right now. That looks good.
All right, good. Okay. So let's jump down to this one, just in the essence of time. So one of the things too is we're looking at building some fractional understanding. Is a game I used to do with my students called Missing Numerator, Missing Denominator. And so what I've done is kind of give them a template for two particular fractions. And I captured this image from the FX55. So in the emulator software, there's a way to actually grab a screenshot of what's on the display, which is what I did there. So it's why you see this math in the up arrow that's over here, because it's from the screenshot. But this is something you could do. You could write it on a smartboard. You could have it up on the smartboard. Yeah, and essentially what the idea is that you give the students a sum. So let's say, for example, if I'm working with the unit fraction of 1/4, and I want students to come up with something that is equal to 7/4, what would have to be the missing numerator? What would be the missing denominator? And so naturally they would put a 4 over here, they'd put a 6 over here, and that would give them 7/4. We as facilitators in this discussion, we can make that value whatever it is that we want. It is entirely just something to help assess some understanding of students working with these fractions. If I'm working with, let's say, a 4th or a 5th grader, I might ask them to give me a missing numerator and a missing denominator for this problem that equals 7/4, but the denominators can't be the same. So maybe in the first fraction they choose to use a half, or I mean, half might be good if we're trying to get to 7/4, and then it would be 5/4, just to kind of build some understanding there. And it works also if you want to do it with a subtraction problem or a multiplication problem, just in the sense of being able to kind of tap into some strategic thinking to hit maybe into some higher depth of knowledge when looking with some of these activities to help students understand as they're working with fractions that are here. Another thing that I've done too is this little fraction game that uses the random number generator on the calculator. And so we'll try an example of this right now. But you take the notion of I've got two fractions, and in between them is an operation symbol. So it's either addition, subtraction, or multiplication in this case. And I'll generate four numbers, and the idea is here to come up with two fractions that have the largest sum, and then use those same four numbers to come up with two fractions with the greatest difference, and then two fractions with the largest product. So the way I'm going to do that is I will generate a random number, I'll generate a random digit here. So I just want one number to appear up from 1 to 9, and I'll hit the equal button, and I have the number 6. So wherever you're at, just kind of write down the number 6 so you capture that. And then we'll look at the next digit, and that's a 3. And we'll look at the next digit, that's a 2. And we'll look at the next digit, it's a 7. Okay. So the digits are 6, 3, 2, and 7, which is what we came up with. So if I wanted to generate two fractions that would have the largest sum using those digits, what would it be? And if you come up with an answer, if you want, feel free to go ahead and actually type that answer in the question box. And Dee Dee, if anybody comes up with an answer for us, maybe you can share it with us as a group.
All right, that sounds good. I'm watching for some answers.
All right. So again, we're looking to place these, and you can only use the digit once. So once and only once. Dee Dee, if you were solving, I'm going to put you on the spot, Dee Dee, if you don't mind.
Okay.
If you were solving this problem, what would you want to do to get two fractions with the largest sum?
I would probably choose to put the larger number over the smaller number, the smallest number, as one of my fractions. I'd have 7 halves, and then I would add to it the next largest number over the second next to the smallest number.
And why would you do that? What's the reasoning behind that?
You said to try to create the largest sum,
right.
So I wanted to try to go ahead and gain some whole numbers that I would be adding together as well as the fractional parts.
So what I've typed in on the screen there, is that something that you did?
Yes.
Okay. And so we've got 33 over 6.
Correct.
Right? And that I believe is 5.5.
Right.
Right, okay. So if I want to take a look at it as a, let's see, get out here by 3, get 11 halves. All right. So that's 5.5 there, okay. So what I like about your reasoning there, Dee Dee, is that you were able to take, you were able to take the notion that, you know what, I need to put the larger number over the smaller number because that would give me something greater than 1 in this. And so there's something here to talk about some structure in looking for the structure in the problem with these numbers. I mean, we could do 7/3 over 6 halves. Let's try that. All right, so if I do 7/3 plus 6 halves, now I get 32 over 6. That's 5 1/3. All right, so not as large as 5.5, but the reasoning is there. The reasoning's pretty solid, right? About saying, you know what, if I'm dealing with a fraction, I'm adding them. I want a larger numerator over a smaller denominator to help me with that. If we were to take these same digits, 6, 3, 2, and 7, and create a subtraction problem in which would give us the greatest difference, what might we look at here? Right, so again,
Are
this
you
is an
turning that question back
opportunity.
over to me?
Yeah, no, well, no. I was just going to say, I mean, this is another opportunity where, you know, there are some students I've done this with, their entry point is to go in and just kind of guess and check and kind of just plug in some numbers and see what's the greatest difference they can come up with. But I think eventually, if we're doing this instructionally, we're doing it as a think aloud, or we're trying to get students to think about the structure or the repeated reasoning within this problem,
Right.
you know, what would be the numbers they would place there and why?
Okay,
And-
you still
and
wanted
so-
a greatest
Yeah,
difference, right?
Right.
All right, so would you leave the 7 over 2, because that's still going to give you the greatest number to start with, the greatest value, and then subtract 3 over 6 instead of 6
Yeah.
over 3.
Exactly, right? And so we get 18 over 6, which we know is going to be, 3, right? 3 over 1. So I think what was helpful for me when I did this in the classroom too is that it just opened up some really good discussion out of something, rather than just doing, okay, here's an addition problem, here's a subtraction problem, find the answer. And the way that students, I truly believe, get an ability to do this is in the understanding of that unit fraction. So they know what a half is representative of, or what an eighth is representative of, and looking at that in terms of, you know, if I have 7 halves, that's a rather large number as opposed to 2 over 7 or 3 over 2. So again, it's just another you know, tool for your toolbox, if you will, about being able to engage your students in some understanding about, you know, reasoning abstractly and quantitatively, but looking for some structure and repeated reasoning. Those math practices 7 and 8 that that really take a look at some of this understanding here. So are there any questions about the particular game? Any thoughts about the game? Anything from anybody? All right. Well, I want to be respectful of time. I do want to spend a little bit of time taking a look at some of the sample released items that the Smarter Balanced Assessment Consortium has put out. These are on their website. They are accessible to everybody. And what is particularly, I find, nice about these items is that they are far beyond the traditional multiple choice type questions that we see. So these are all 3rd, 4th, 5th grade items, and again, they are on the website. The website is there. If you just Google Smarter Balanced Assessment Consortium sample math items, they'll come up pretty quickly. But let's take a look at a couple of these examples that are here. I'm actually going to back out of this, and I'm just going to go on the website itself so we can see it here and kind of do it live. So here we have our stem over here. Look at point P on the number line. And it says, look at number lines A through E. Is the point on each number line equal to the number shown by P? Choose yes or no. So what are we basing this off of? We're basing this off of that this is one whole unit. And that one whole unit here is from 0 to 1, and each unit is broken down into different segments. So if I look at A, there's a lot of little tick marks that are here. In fact, there are 12 equal segments, and 1, 2, 3, this is 4. This would be 4 over 12. Is 4 over 12 equivalent to 2, 6, which is here? And the answer to that is yes. Okay. Here we have 6 equal units. Same thing as what we have in the stem, but this point is a little bit further to the right, so it's not equal to point P. We would click on no. Here we have 5 equal units. This is on the third one. That would also be no. And of course, this would be yes, and this would be no. And then we can go over here to our item score, and we can click on it, and we get some feedback as to whether or not the answer is actually right or not. Okay? This item here is aligned to 3NF3A. And it's understand two fractions are equivalent if they are the same size or the same point on the number line. Another item I'd like to take a look at is this item here, which is 43328. This item here is 4NF4C. And just to reference it with where the standard is, the standard reads, solve word problems involving multiplication of a fraction by a whole number. All right? So here, we're not looking for an exact answer. Okay? Jared's testing how much a weight a bag can hold, and he puts juice bottles into 3 bags. So he's going to go over here, he's going to take a look and drag on this bottle, and he's going to say, okay, well, if I put 1 bottle here, is that between 6 pounds and 7 pounds? The answer is no. So I'll put another one in here. And is that between 6 pounds and 7 pounds? And we want the student to know, well, you know what? 3 plus 3 is 6, and 5/8 is a little bit larger than a half. And I know that 2 halves is equal to 1 whole, so 6 plus 1 is 7. I've got a little bit more than 7, so it's not going to fit in this bag. Could it fit here between 10 and 11 pounds? And I'll put one more in here. Seems to be right, I think. Yep. And we'll drag some over here and see. And again, the notion here is to not come up with the exact answer, but to determine whether or not multiplying this particular weight by a whole number is going to fit within the range here of these two numbers. And we'll click on the item score, and yeah, these are all right. Okay. And then the last item is here, and this is 43051. Now, give you a moment just to take a look and read this problem on your own so you can see this item. And the standard here is addressing about solving word problems involving addition and subtraction of fractions that refer to the same whole and have like denominators. And what students would do with this item is they'd actually use the keypad that's here on the bottom, and they would enter in their answer. But again, this problem here in particular is building on the notion of a unit fraction and those multiple parts. Right? So we have 3 large sandwiches, and each person ate a different amount. So how much would be left for Oscar? And in thinking about this, right, the student has to have the understanding of that unit fraction of a fourth. There are multiple ways that a student can actually go about and solve this problem. Whether they do it computationally, whether they draw a model. They could do it as a bar model. If students are familiar with Singapore math and using the bar model method, they may draw a number line and section everything out. It's just flexible. There's a lot of different ways that can be done here. And I think the good thing, what I like about these particular questions here as they're released for the public and shared, is that a good assessment item is an item which is aligned to the standard, is challenging, it's interactive, it's engaging for a student, and it's going to give us an understanding as to whether or not the student actually is proficient in meeting the requirement for that standard to demonstrate that knowledge on that particular topic, which here is just about solving an addition or subtraction problem with fractions that have like denominators. If you have not had a chance to go on the Smarter Balance website to take a look at some of the released items, I certainly encourage you to do so. If you've had a chance to go on the PARCC website, which is PARCC, it's the Partnership for Assessment of Readiness for College and Careers. It's the other National Assessment Consortium. They have some released items on their website as well. They're great tools for teachers that are looking for different ways to help assess our students' knowledge of this particular concept and idea. And it just really allows some kind of different thinking or outside the box type thinking on some of these items. It's a little bit more engaging. So with that, Dee Dee, do we have any more questions?
I don't see any questions. I think that's it.
Dee Dee, is there any other points or things like that you think we need to make in this webinar before we call it a night and thank everybody?
I can't think of anything. I know that it's really good to see the thoughts going into this because I teach high school math, and even a lot of the concepts that they struggle with, even in pre-cal calculus, go back to understanding how the fractions and the computations of fractions. If they can't do that, they can't do the calculus. So it's good to hear these explanations going on in earlier grades.
Absolutely. I mean, it's so true that what students gain along the way is going to help them for whatever they're going to do in terms of if they go to college or whatever career path that they take. But that fractional understanding is so key across so many things that we do in our everyday life. And you're right. It is nice to see that these conversations are happening, and they're rich conversations and they're rigorous conversations. I said at the beginning it was really hard to talk about this broad of a concept in the scope of an hour, but I hope that the conversation today at least has given you some things to either take away or think about how the whole importance of a unit fraction plays within building a student's numerical reasoning and understanding of this whole concept around fractions and how it builds, as we saw in the diagram from the Common Core and the Illustrative Mathematics Project, about building into a student's understanding of ratio and proportional reasoning. There is so much to do, and we're still, unpacking and challenging and delving into what exactly all these standards look like. And it goes without saying that people are doing a really, really good job out there of taking this information and engaging students in these kind of conversations. I hope what we at Casio America shared tonight and what we as members of the Teacher Advisory Council shared is helpful, and certainly encourage you to take a look either at Casio's website, casioeducation.com, to take a look at some of the materials and resources that we have up there. If you like the calculator that we used tonight, definitely take a look at that too. It's a really neat tool, and I've certainly enjoyed using that as well. So without any questions at this point, Dee Dee, I want to thank you so much for your help tonight with the webinar, and wish everybody a good night and keep up the great work.
Thank you, John. We enjoyed your presentation.